Okay, today we're going to talk about repeated sprint ability. As you know, many sports require the ability to continually sprint over and over and over again, such as hockey, for example, or soccer. So basically, what is repeated sprint ability? You know, athletes engaged in many sport disciplines are required to repeatedly produce maximal or near maximal efforts, interspersed with brief recovery intervals. Okay? And this consists of complete rest or low to moderate activity. So for a game, this could be completed over 1 to 4 hours. So this has been termed repeated sprint ability. So I want to differentiate this. Intermittent sprints, you might have 180 to 300 seconds where full recovery is possible. But with the repeated sprint ability, you may only have 60 seconds, right? So if you look here, intermittent sprints are the dark gray, repeated sprints are the light gray. When you have longer rest periods, you can maintain work. But with repeated sprints, short rests, your performance goes down. So one thing we know is if you look at basically what they're looking at here is essentially high-level players, right? And these are soccer players, intermittent sport, and that's the black group. And you have moderate-level players. If you look at graph B, okay, or the right side of this graph, notice that from minutes 0 to 15 of the game through 90, essentially what we're seeing is that the ability to maintain high-intensity running is always higher in the high-level players, right? So basically that's an example of repeated sprint ability. They're able to continually run at high intensities during the second half of the game compared to the first half of the game, and whereas the lower players are not. Okay, and that's the difference, is when you wear on your opponent by continually being able to repeat at high intensities. And again, this is likely what separates people when we talk about games. You know, if you think about it, even if you lose like 20% of your ability to sprint by the last quarter, you know, or the last fourth of the game, while the other team's able to maintain, they're going to smoke you. And that's kind of key. We're trying to maintain that ability to maintain high intensity performance. So what limits repeated sprint ability? One, if you look at sprint 1 to sprint 10, so they did 10 sprints with 30 seconds rest, you see clearly differences in power output. One of the things we think that's limiting repeated sprint ability is muscle activation. So if you look at normalized electromyography, which is muscle activation, so from sprint 1 to sprint 10, you can see that muscle activation goes down from sprint 1 to sprint 10. What you're looking at here is a technique called twitch interpolation. So basically, you see that what you're looking at is essentially force output. And you have force output, which represents, you know, a portion of your motor unit's recruitment, and then you superimpose electrical activation. The difference between the superimposed twitch and force output without it is how much central drive you're missing. If you notice before sprinting, you see it's a small difference, meaning that you're recruiting most of your motor units. But if you look at after sprinting, it's a much larger difference. What that means basically is that your central drive is going down. And of course, PCR goes down. So phosphocreatine levels, you see the first sprint from beginning to the end of that sprint, you see phosphocreatine goes down. But the last sprint, you're starting at much lower levels, like 50% of levels, and it goes down. So that's very, very important. So because remember, phosphocreatine is critical for repeated sprint ability. So what's important is that recovery of phosphocreatine seems to be a primary determinant of recovery from repeated sprinting. Okay, so these findings suggest that the performance of repeated sprints may be improved by training interventions that increase the rate of resynthesis of phosphocreatine levels. That's very, very important to understand, right? So what replenishes phosphocreatine? Well, basically, think about it. When you do a sprint, after the sprint, you're huffing and puffing, you're breathing at really high rates. Well, it turns out that the oxidative system is what's recovering your phosphocreatine levels. And that's what we sort of see here. If you put someone in a hypoxic state, which is the lower end of this graph, the dark line, basically it takes them much longer to recover their phosphocreatine source. If you put them in a hyperoxic state where oxygen is more available, they recover PCR levels faster. And we know that there's a large relationship between, for example, VO2 max, or maximal oxygen capacity, and the ability to recover phosphocreatine source. Intriguingly enough, in this study they did 5 6-second sprints, and what they saw is that the contribution of aerobic energy from sprint 1 to sprint 5 went from 90 to 40%. That means 40% of the energy they were using after the 5th sprint was from aerobic energy, and it keeps going up and up after that, which is surprising to many, but the point is the more you sprint, the more you're relying on aerobic capacity. Okay, so this hypothesis explains why subjects with a greater VO2 max are able to maintain power output in sprints better. In fact, we see a relationship of 0.45 to 0.7 between VO2 max and repeated sprint ability. So how do we train for repeated sprint ability? Well, this is a study where they did 6 to 12 basically sprints, so 6 to 12 sprints, and the sprints consisted of 2 minutes at 100% VO2 max, and they rested 1 minute between. So that's clearly an intermittent, or excuse me, that's clearly a repeated sprint ability. What I want you to look at is what you're seeing is resting levels of PCR concentration. Okay, the dark gray is after they trained for several weeks, and the light gray is before they train. So notice immediately after they sprint, both of their PCR levels are down around the same. But 60 seconds after, the post-training group, the 6 to 12, 2 minutes of VO2 max group with 1 minute rest, recovered PCR faster by 60 seconds. Whereas at 180, there's no difference. So where it really makes a difference is when you're having to do repeated sprints over and over again. But one thing I want to point out is that VO2 max seems to be affected mainly with longer rest periods between sprints may be better. So this is a study by Hazel, and basically if you look at VO2 max changes, okay, they had one group do 30-second all-out sprints for 4 to 6 reps with 4 minutes rest. You can see that's the first graph. They got a 9.3% increase. They got a 9.3% increase in VO2 max. If you look at the 10-second sprints for 4 to 6 reps with 4 minutes rest, they also got a 9.2% increase in VO2 max. But when they only rested 2 minutes, they only got a 4% increase, or 3.8. And it's likely because to increase VO2 max, you need every single sprint to be maximal to drain the system of PCR to the greatest extent. So for VO2 max, it's all-out high-intensity sprints with longer rest periods, like 4 minutes in length. But one of the things to understand is that long rest may actually decrease intramuscular lactate. So what you're looking at here is if you do a sprint at 0 minutes recovery on the top, you see lactate levels, and as recovery continues, lactate levels goes down and down and down, and pH recovers. So what about lactate? Because that's likely also limiting repeated sprint ability. So we have a study here where they do long rest periods. They did 30-second sprints with 10 minutes rest. That right there, what you're seeing here, is intramuscular buffering capacity before as you see, is 6.78. And we look after, that's intramuscular buffering capacity, no change. So the problem is you might increase VO2 max, but if you're resting too long, you don't increase buffering capacity. And we also need to clear hydrogen ions, for example, from repeated sprints. It's not just VO2 max, it's not just PCR recovery. So if you look at this study, they did interval training with short rest period lengths, 30 to 60 seconds. And if you look at VO2 max, that's the left side of the graph. You see the control and the intermittent sprinting. From pre to post training, they didn't increase much. But if you look at intramuscular buffering capacity, if you look at the control group, it didn't change. If you look at the intermittent group, buffering capacity went up a lot. So interval training with short rest period lengths, like 30 to 60 seconds rest, is good for buffering capacity, but not good for VO2 max. So you likely need a combination of shorter repeated sprints with 30 to 60 seconds rest, and then longer intermittent sprints with like 3 to 4 minutes rest on separate days. So if you look at the type of interval, this is something real important here, okay? Basically, they're doing sprints, okay? And obviously, the lower the number, the faster they are. So if you look at before, you have two groups here. You have the SET, which is a light gray. And SET is speed endurance training. So they performed 8 30-second runs with 1.5 minutes rest at 130% VO2 max. Then you have the ST group, which is the dark gray. And what they did was they performed 6-second all-out sprints. Everything they had with 1 minute rest. So obviously, if you look at before, from sprint 1 to 5, obviously sprint time increased. And the reason why sprint time increased is because they're getting slower. If you look at after, sprint time decreased with the faster 6-second sprints. That makes sense, right? Because they're sprinting faster. It's not 1 minute and 30 seconds. If you want your initial sprint time to improve or go down, in time, which would mean improvement in sprint performance, you want to sprint all out really fast. But the group that trained for 30 seconds, their sprint time didn't go down, okay? What I want you to see is this, though. From sprint 1 to 5, they became slower and slower in the sprint group, okay? The ones that did 6-second sprints. But if you look from sprint 1 to 5, and the group that did 30-second sprints at 130% VO2 max, that was maintained. So what this says is that for mean sprint time and peak velocity, repeated sprints is probably best. But if you want, but speed endurance, which is like the longer sprints, could be good for maintenance of initial sprint velocity. So again, you want a combination of both. You probably want to combine short all-out sprints with short rest to decrease initial sprint time. You probably want to have a little bit longer sprints so that you can maintain the sprint from sprint 1 to 5 or 1 to 10. Okay? You want short rest period lengths for buffering capacity and long rest period lengths for VO2 max. We also, again, see here that resistance training at 12 to 15 repetitions with 20 seconds rest induces a lot of metabolic stress. And what happens is if you rest for 20 seconds, basically what you're seeing is if you look at the pre-values of how much work was done, with 20 seconds rest, which is open triangles, to post-closed triangles, they were able to perform more total work from sprint 1 to 5. However, when you rested 80 seconds, which is the closed circles before, to the dark circles after, their buffering capacity wasn't as great, so they didn't have as great of sustainability of repeated sprint ability with resistance training. But it's likely that you will increase your strength more if you're resting longer, which is better for the initial sprint. So in summary, it's likely that for initial sprint ability, you need strength and in general power. Once you've acquired that, once this requisite is attained, you need to improve VO2 max capacity and buffering capacity. VO2 max is optimized at 10 to 30 second sprints with long rest periods, and buffering capacity optimized at 10 to 30 second sprints with short rest periods, with 1 minute or less. So you will likely want to periodize for repeated sprint ability, okay? So again, you take an athlete, they're weak, they need to increase their strength. Once you have their initial sprint up, you need to actually improve their ability to replenish PCR, which is going to be the 10 to 30 second sprints with long rest period lengths. If they're a repeated sprint athlete, I wouldn't recommend doing like long runs. It's going to make them slower, their initial velocity slower. For buffering capacity is optimized at 10 to 30 second sprints with short rest period lengths, meaning 1 minute or less. Thank you guys, and I'll see you soon. Actually, sorry. One more thing. Repeated short sprints may be better for overall velocity and decrease mean sprint times. However, longer intervals may be best for maintenance of initial sprint velocity. Finally, with heavy resistance training, it's important for overall power and initial velocity to have higher rep training with shorter rest period lengths, and greater metabolic stress may be better for repeated sprint ability after strength levels have reached an ideal limit. Okay. So again, if you're training for resistance training, if you do metabolic training, like Joe Walters likes, for example, you'll probably improve repeated sprint ability.